All right, here's the last thing that we're going to talk about, and it should be something that you've heard of before. You guys heard of the quadratic equation? Okay, here's what the quadratic equation allows you to do. It allows you to find a solution to any quadratic form that's in this form, this standard form. Have ax squared plus bx plus c. Okay, all this means is you need to write your equation in order from highest degree term or highest power to lowest power. So the power of x is 2, then 1, and then the constant with the power of 0 for the x. Okay, and so if you write your equation in this form, the quadratic equation allows you to solve for x, find the solutions of this equation by plugging it into the following formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And now, if you notice on here, okay, so here's the quadratic equation. All right, is it going to be absolutely necessary for you guys to use this in this particular class to solve an equation that's set equal to 0? Is this going to be the easiest way to do it? No. What's going to be the easiest way for you guys? Calculator and enter what? Yeah, just solve, right? Just use the solve function. And I just want you guys to be exposed to this because you may be in a class where teachers don't allow you to use your calculators like I do. And this is the formula that you might need to use in order to calculate a solution. All right, if you look at this first part, if you were to divide this equation into the two separate parts, you get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Well, what do you notice about this part? Have we used this already? Negative b over 2a. Does that look familiar at all? Yeah, this was the x-coordinate of the vertex, right? And so here you're finding the x-coordinate of the vertex and then you're making some change to it. Now, would it make sense that that change, so like if you're plotting your, let's say your vertex is right here, and with this vertical line of symmetry passing through it, would it make sense that the next x value, or when you're looking at the solutions, now what this allows you to find are any solutions when you're solving for an equation mean x-intercepts. It's the location where the graph passes the x-axis. So would it make sense that, let's say your graph opens down like this, would it make sense that you're adding and subtracting the same x-coordinate here and here to get your x-intercepts or your solution points? Okay, this line of symmetry means that it's exactly the same mirrored across it. So would it make sense that the distance from this x-coordinate, the vertex, to your x-intercept is the same as this distance to this other x-intercept? Okay, so this is why kind of the plus or minus occurs. You need to understand that quadratic equations can have one of three types of solutions. Okay, here's a case where you have two solutions. Okay, you could have a graph that looks like this. It can open up or down. But if the vertex is on the x-axis, are there going to be any other points that intersect with this x-axis? Will there be any other x-intercept if the vertex is on the x-axis? No. So you could have one solution. Oops. Or you, again, it can open up or down in either of these cases. You could also have something that looks like this. If your vertex is below the x-axis and it opens down, is there any way these lines will ever pass or cross the x-intercept or the x-axis? No. So you could also have zero solutions. Okay, now the way that you can tell whether it's 1, 2, or 0 is looking at just what's inside. This is called the discriminant. Again, we're not going to emphasize this at all. What I'm simply going to ask you regarding 1, 2, or 0 solutions can be found just by either using the Y editor and sketch your graph, or using the solver and just identifying do you or do you not have 0, 1, or 2 solutions. And so if I ask you to solve this equation, all right, so solve this equation using your calculator. Are you going to plug it into the quadratic equation? You could. If you did, what would the A value be? 1. What would the B value be? Positive 3. And the C value would be a negative 4. Okay, however, you don't necessarily need to do this. You can simply type it into your equation solver. So F2, the algebra tab, hit solve. Type your equation exactly as it appears. X squared plus 3x minus 4 equals 0. Solve for x. And when you solve this, you get your solutions. X is negative 4 and 1. Bless you. Okay. So x equals negative 4, x equals 1. Okay. These are your x-intercepts. Okay. So when you're looking at your graph, these are the 2 points where your graph will pass the x-axis. So what are the y-coordinates here? The y-coordinates will be 0. So the solutions are really negative 4, 0 as far as the coordinates go, and 1, 0. Okay, so how many solutions do you have with this equation? You have 2, right? 1, 2. All right, what if we took, instead of this, the equation x squared plus 3x plus 4 equals 0? Let's see if we solve this one. So the only difference now is there's a plus in between here. What happens when you try to solve this? It says false. And what does false mean in these respects? No solution. What that means is, first of all, is this graph going to open up or down? It's going to open up, and it'll still have a vertex. It'll still have a y-intercept. The only thing is it's not going to cross the x-axis. So that means that if it opens up, that means its vertex is going to be above the x-axis to start with. So false means no solution. Okay. Or if I was asking you how many solutions does this have, your answer would be 0. All right, let's do one last one. What if I said x squared minus 4 is equal to 0? How many solutions does this have? 2 solutions. And those solutions would be what set of coordinates? So negative 2, 0, and 2, 0. And so those would be your 2 solutions.